Okay, this is lesson 73, compound interest. So today's a conceptual lesson. Compound interest has to do with exponents. It's an exponential model. And so whenever someone has money, you could be earning interest. So whenever you go to the bank, okay, you're telling the bank, hey, I'm going to let you borrow my money for interest. Right? You put the money in the savings account and they say, okay, we'll pay you this interest. So they're basically borrowing your money. Say, yeah, I'll take your money, and I'll pay you this interest, okay? So interest is extra money you earn when you save at the savings account. You all know that, right? Okay, and what that bank does, what banks do is they take your money, and they say, we'll hold it for you, but they don't really hold it for you. They actually lend it out to other people. There's other people that come to the bank, they're like, oh, I need to borrow money. And so when they borrow money, they have to pay interest. Does that make sense? Like a credit card, or maybe they get a loan for a car, or maybe they get a loan for a house, right? Y'all follow me so far? Or there's businesses that are like, oh, I want to open this sweet new restaurant here in San Dimas. I need $100,000 to start my business. So the bank will be like, okay, we'll lend it to you. Okay? So interest is usually compounded monthly, but sometimes it's compounded continuously. When that's the case, we use the Euler's number, okay, which is E, which is an interesting number because it works in finances too. But let's go back to compound interest. Let's say you had $1,000 and you took it to the bank, and the bank gave you 10% interest, okay, every year. Okay. After 1 year, you'll have earned 10%. What's 10% of 1,000? 100, right? So in a year, you're going to add $100 to your account. So in 1 year, how much money will you have at the end? $1,100, right? Does that make sense so far? And then after year 2, what's 10% of $110? Or 10, I just give you the answer. What's 10% of $1,100? 110, right? It's a little bit more interest. Did you all see that? So in 2 years, you're going to have $1,210. And then what's 10% of this value right here? 121. That means the bank will pay you on the next year $121. Do you see how your interest that the interest you're getting each year is growing? Do y'all see that? Yes or no? Y'all understand this concept? This is called compound interest, right? It's not just $100 every year. It is compounding. So you're earning money on interest, right? Interest on interest. So that's pretty cool, right? And the opposite's true too. Like if you borrow money, you're paying interest on interest. Okay. Here are the steps for today. So we're talking about continuous interest. This is the continuous interest formula. There's 3 parts you need to know. No, 4 parts. This is the final amount you're going to get after so many years. P is the principal amount that you are saving. E is Euler's number. We know that already. R is going to be the rate of interest. And T is the time in years. Okay? So here we go. Here's number 1. You don't have to write this down unless you want to. It's fine. That's good. I pull up my old presentation. So I'm going to read this out loud. Just follow along. Suppose you invest $1,050 at an annual interest rate of 5.5% compounded continuously. How much money to the nearest dollar will you have in the account after 5 years? Okay, so the first thing you want to do is identify the parts of the equation or the parts of the problem. So the key word that I see up here is compounded continuously. Since that's the case, I want to use this formula that I wrote up here. A is equal to principal times Euler's number to the R times T power. Okay? Now I need to start identifying parts of my equation, right? We know A is the final amount, right? So I have to figure out what part of my numbers are the final amount. P is my initial amount or original amount. Rate is the rate, okay? So in this case, my interest rate is saying 5.5%, right? So I kind of have to think, what is that equal to? And time is how long it takes. Okay, so let's start. What's that? E is Euler's number, that little button on your calculator. E is 2.81. Remember natural log, base E. So called it's Euler's number. We didn't go into that yet. Well, we didn't go into the history of that. So rate times time. So and principal, we have to figure this out. So we have to figure out the parts of the equation we're given. So originally we're given the initial amount or original amount you're saving, $1,050. Okay. So we're going to bring that down. We know what E is, the rate. Okay, I have to think about what rate is. So let's think about what the rate is. What's the rate that's given? 5.5%, right? So let's think way back to 6th grade math. How do we write 5.5% as a decimal? Well, you just move the decimal point 2 places to the left. So it's actually 5.5% as a decimal is 55 thousandths, okay? So just a little flashback. You should know this already, but just a review, okay? So whenever we write rates as percentages, you have to use the decimal point form. So we're going to bring that down to our original problem. Okay. And then time, it says, what's my time? It says 5 years, so I'm going to multiply that. Okay. And then the thing we don't know is A, right? The final amount, because that's what it's asking. Okay. Because it says how much will you have at the end. Okay. So we don't know that, so that's our A. So now we're going to solve for A. A is already isolated by itself on the left side of the equation, so I just need to do my calculator work right now in one fell swoop, okay? So I'm going to use PEMDAS, right? So we have parentheses in the exponent, so I'm going to solve my parentheses first, and then put that to e to that power, and then multiply that by 1,050, okay? So thinking ahead what I'm going to do. Taking my calculator out, clearing my old calculations. Okay, here we go. So we have our parentheses first, which I'm going to write 0.055 times 5, and I get my 0.275 in my parentheses. Then I can use the e to the x button to get this value here. So e to 2.75 gives me some huge decimal. Then I multiply that by 1,050, and I get 1382.357. Okay, so I'm going to write that down because this is money now, so I don't have to go to write all my decimals out. Okay. The question is asking how much to the nearest dollar. So I need to go to the ones place here. We have a 2 there. Looking to the number to the right of the 2 is a 3, so it's not 5 or more, so I won't round up. Keep 1382 the same. So after 5 years, if I were to put this money into the bank, I'd have $1,382. Okay? That's it. Again, so what did I do? I read the problem. Always read your problems when you work them out. Okay? It's asking what about compounded continuously interest. So, looking up here, I know I'm going to use this formula. I'm going to figure out what I know already. I know that the principal amount was 1,050. Put that down. E is just the number E that's on the calculator, 2.81. And then we have rate. We know is 5.5%. I have to convert that to a decimal. Okay. Put that down here. Times 5 years. And then I started working this out PEMDAS. We have parentheses. Then I used the exponents. And then I multiplied. And then I got this final answer here. Rounded to the nearest dollar for this particular problem because that's what it asked for. It's 1382. Okay. Questions on number 1. We're only going to do 3 examples, so I'm going to have you discuss this with your neighbor. Okay. So turn to your neighbor, get to know him a little bit more. Tell him how did I do this, and then one of you explain how did I figure out this rate, and then explain the calculation. Ready, set, go. 2. Suppose you invest $1,300 at an annual interest rate of 4.3% compounded continuously. Find the amount you'll have in the account after 3 years, okay? Okay, so let's say you came freshman year as your first day at school, your parents are like, hey, you got some savings, you should save it. Start saving for whatever. You're like, okay, go to the bank, you have $1,300, and you kept that there all the way until your senior year. You're like, I need money my senior year because I go out with my friends and I just hang out all the time and I need the money. So you had an interest rate of 4.3%. How much will you have after 3 years, okay? So let's work this out. Compounding continuously, let's start with the formula. A is equal to principal times e to the r times t. Okay. So what information is given in this particular example? What does the problem give us? The rate and time. Okay, so what's the rate? 4.3. How do I write that as a decimal?
0.043.
Good. 0.043. Y'all got that? What's my time? Good. And what did I invest? Good. So that's principal or the A? Principal. So we're going to put that down. So we start with our time, 0.043. Bring down E, right? Principal is 1,300 is equal to A, right? Now I'm asking myself, this next, identify the part that's missing. The part that's missing is A, right? Fortunately, A is already isolated, so all I got to do is just calculate this. So you do just what you did on the last one. So why don't you do this one by yourself, and let's see if we get the right answer. Ready? Set.
Do you still run the
Go.
different ones?
That's the answer for number 2. Now, the opposite is also true, okay? This is how much money you'll have to save after, or have saved after 3 years, right? You see that? You had 1,300, so how much does your money grow? $179, right? In 3 years, right? You just left it there the whole 3 years you were in high school, and then your senior year you're going to have $79 extra dollars, right? The opposite's also true. Let's say you wanted to buy something for $1,300 and you didn't have the money, okay? What could you buy for $1,300? Give me some examples. What's something you would buy? Clothes.
Car rims.
What?
Car rims.
Car rims. Okay, what else? Anything else?
Easy as pay driving.
Okay, so let's say you wanted to get, you're like, I need all these clothes right now. I gotta have $1,300 worth of clothes, okay? So you get a credit card, right? And you go buy $1,300 worth of clothes. They let you borrow all that money, okay? But after 3 years, you have to pay back. You have to promise to pay back $1,479. So now your $1,300 worth of clothes is now how much? Worth how much? $1,479. Is it worth paying that much for clothes?
No.
No. Okay. And that's a really good lesson to learn now, because in college, I'm going to tell you this, they're going to, when you get to your campus, like I went to Cal State Fullerton, and they're like, as soon as I got there, they're like, oh, here's the free beach ball. Welcome to school. And I'm like, cool, thanks. And they're like, you get the free beach ball if you fill out a credit card application. And you're like, a lot of kids are like, okay, you know, I'll get a free beach ball, whatever. And they don't think what it is, and they might give them a $1,300 credit line or a $1,000 credit line, so they start charging the card, right? Is that free money when you charge your card? No, it's not. You have to pay that back. And unfortunately, interest rates on credit cards are not 4.3%. They're at least 12, 14, 15, sometimes even as high as 30%. Okay, so it's way higher. So imagine, you know, going on a shopping spree or whatever. And credit cards are real dangerous if you don't know how to use them. So it's really important that you understand this concept, because, right, you don't want to be in debt. It's a vicious cycle. All right, next one, number 3. Okay, let's think about, this one's a little differently. This one we got to think backwards, okay? So let me just say a story. Let's say 10 years ago, your parents, like, they won the lottery, they got all this extra money. They're like, oh, we should save money for, you know, our son or daughter to buy a car when they're 16. So let's pretend you were 6, you didn't know that they won all this money, but they started saving money for you, okay? So when you turned 16, you found out that you had a 10-year-old savings account that contains $12,840.25. You're like, hey, cool, you just threw your quinceañera. That was a year late, okay? And it earned 3.4% annual interest compounded continuously. How much was initially deposited? Okay? So we're trying to figure out how much money did mom and dad save for me when I was 6, okay? You're thinking backwards now. Okay, so it says compounded continuously, so we need to use our formula, because there's different formulas for each application, okay? So this one is continuously compounded. What information do they give us right now?
Time.
The time is what? 10 years. What else do they give us?
3.4% annual.
3.4%. And what else do they give us? What, at what point?
The A's.
The A, right? Did you all hear that? The amount in the account is the A or the P? A. Do you all understand that? It's how much you have at the end. So now we're thinking backwards. What was the original or principal amount? So we're going to put the numbers in. We have A is equal to 12,840 and 25 cents. We don't know what the original amount is, so we're going to put P down. That's the question. And then we know E is Euler's number to the rate. How do I write rate, or the rate in this example? 0.034. Good. Times. What's our time? 10 years. Okay. So I'm going to put parentheses around that calculation at the top because that's all one exponent. Okay. What's step 2? What part of the equation is missing? P. Okay. Is P by itself right now? Is our principal amount by itself? No, we need to solve for it. So we're going to divide both sides by this E. This whole term right here. We're going to put that into the denominator. Okay, so we're going to divide both sides by that. So we're really going to be calculating 12,840 and 25 cents divided by E to the this power, which is equal to P. Okay? I'm going to put this into my calculator here. Okay, clearing my calculator. 12,840. So the first thing I want to do is make sure I calculate this parentheses down here. So I'm going to put this into, multiply this out. I get 0.34, and then I use E to that power. I get decimal, and since I have this decimal, I want to put it into my memory because I need to divide that amount. So I'm going to put it in my memory. Then I'm going to put 12,840 and 25 cents. Divide that by that amount. Press equals, and I get this value. Our principal amount was 9,139 and 31 cents. Right? That means 10 years ago your parents put this money in the account. $9,139.31. So over 10 years it's grown over $3,000. It's a lot of money, right? Okay. Anyways, that's what compound interest is. It's really important to understand this concept because all of you will be dealing with monies, and you'll either be saving money or borrowing money, okay? Or both. So if you're saving money, hopefully you put it in a good account that saves you interest. And if you borrow money, hopefully you understand how they charge you interest. Right? Because if you don't understand that, you could get into some big trouble. There's a lot of adults that didn't listen in high school that are struggling week to week, month to month, paycheck to paycheck, and they don't know how to get their financial act together. So it's really important you understand this now so that you're ready when you're an adult on your own. Okay? That's it. That concludes this lesson.